Okay, we're moving on with writing expressions in factored form. Yesterday, when we factored, you kind of looked for a common factor between the terms. So if it was, just one term, two terms, or three terms, you look for the greatest common factor, and then we pulled that out, right? We factored that out. You had to divide each term by that factor. Well, and if you had four or more, you had to group them. Well, today we're strictly working with what we call quadratics, and that's to a second degree polynomial. And so our main quadratic right here, x squared plus bx plus c, we're going to work on factoring that today. And when we factor a quadratic, it factors into a product of two binomials. For example, right down here, a product of two binomials. So I got a binomial, and we're multiplying. That's where I say product. Okay? So when we factor quadratics, we should end up with something like that. So I'm going to talk about it algebraically right away. It might confuse you a little bit. Once we get to an example, it should start to make more sense. So when we factor our quadratic, basically we're going to come up with two integers. In this case, I'm calling them m and p, right? They're going to be factors of c. They're going to be able to multiply up to c. So factors of c, and they're also going to add up to b. Those are our two rules. So I'm going to come up with two integers that are factors of c that should add up to b as well. And this works algebraically if I look at my two binomials here, x plus m times x plus p. So if I go through my FOIL, I take x times x, I get x squared. Take x times p, and then, let me write this out, x times p, and then m times x, and I got px plus mx. And lastly, m times p. Well, that m times p, if you notice, that's really our c term in our x squared plus bx plus c, right? So we said factors of c, m times p, m and p. Where the b comes from, why p and m should add up to b, if I think about this, this is really p plus m times x. I could factor out an x there. So that's why the p and m need to add up to b as well. Okay, so kind of confusing. Some of you might get this, but that's how it works algebraically. Let's just look at an example here. Let's make much more sense to you. So let's just start backwards, what we've been doing before. We use FOIL to expand it out. So I'm just going to go ahead and use my FOIL. X times x for x squared, x times 4 for 4x, 3 times x for 3x, and 3 times 4 for a positive 12, and we simplify our x's to a 7x. Okay, just like that. So now to factor, we're going to be given it a polynomial to the second degree called the quadratic, and we're going to get back to this point right here into a product of two binomials. Okay, so I know my answer when I factor is going to be a product of two binomials. So I'm just going to write my parentheses right away, just because I know that's what I'm getting to. And how we start with this is we got to look at our c term right away. So let me write up our standard form of our quadratic, x squared plus bx plus c. We're going to look at our c term, which in this case is 12. So what I want to do, I want to find factors of 12, things that multiply up to 12. Well, I got 1 times 12, 2 times 6, and 3 times 4. And our other rule is that those factors, I got to pick one of the pair of factors that add up to the b term. Right? Because we're saying that the factors of c need to add up to the b term, which in this case is 7. So which one of these add up to 7? 1 plus 12? Nope. 2 plus 6? Nope. 3 plus 4? Yes. So that's what I'm going to use. I'm going to use 3 and 4. Well, to set up my two binomials, I know my first term in each is x, because x times x gives me that x squared. And then, now that I found out that my two factors are 3 and 4, I know that it's a positive 3 and a positive 4. And I could have put the plus 4 and the plus 3, reverse them, but it doesn't matter, right? Because we're just multiplying. So we want to look at factors of the C term, which in this case was 12. And though one of those factors has to add up to your B term, which in this case is a positive 7. And what I usually like to do is, when I deal with this, I like to draw my little X here. And I know I need factors of 12. And I know they need to add up to 7. So that's what I kind of do. I think of like, here's my addition, here's my multiplication. And then I kind of think through my terms in my head. I might have to use a calculator if I have some big numbers. But in this case, I think through and 3 times 4 work out, 3 and 4. And then I know I'm using a positive 3 and a positive 4. And I come back here for my final answer. So I'm going to use this, this x when I do my next one here. So when we factor quadratics, they're going to factor into a product of 2 binomials. So I have a quadratic, right? X squared plus bx plus c. It's in that standard form. So I know it's going to be a product of 2 binomials when I factor this. Okay, product of 2 binomials. And I know the first term in each binomial is going to be x, because x times x gives me x squared. Right? I know that. So I know it's going to be x in that first spot. And so we said our first step again. I'm going to use my big X here now. Is I need factors of the C, right? Factors of 27. So I'll multiply to get 27. That'll add up to a negative 12. Well, I need numbers that add up to a negative number. But they're going to multiply to be a positive number. That should send a little signal to my head. I know that my factors both need to be negative, because they need to add up to a negative 12, but a negative times a negative gives me a positive. So let's take a look at my 27 of my factors. So I need them both negative now, right? Because they got to add up to a negative 12. So I have negative 1 times negative 27, and I got negative 3 times negative 9, and I think that's about all I can think of. Well, which ones add up to negative 12? Looks like negative 3 and negative 9. And so that's all I write in my binomials. Minus 3, minus 9. And I could have put minus 9 first and then minus 3. And I'm done. I'm factored. There's my answer. Right? If I'd go through the FOIL, I would come back to my original expanded form. Okay? So we're factoring. We're going the opposite way of FOIL. Let's take a look at another one. So same thing. I got quadratic, right? X squared plus bx plus c. So I know it's going to factor into a product of 2 binomials. I'm going to make my big X. So I need factors of negative 18 that add up to a positive 3. Uh-oh. Well, they're going to add up to a positive, but when I multiply, they get a negative. So that means one's going to be negative and one's going to be positive. And my positive should end up being bigger than my negative. So let's take a look at that. So factors of negative 18 that add up to 3. So I have, you really don't even need to do 1 negative 18 and negative 1 and 18, because when I add those, they're not going to get you 3. So there's some you don't even need to go through if you know they're not going to add up to 3. So I'm going to go to the next row. I'm going to go with 2 and negative 9, and negative 2 and 9. Those aren't going to add up to 3. Let's go to the next route. 3 times negative 6, negative 3 times 6. And if I look, one of these two is going to add up to a positive 3. It looks like that very last one, right? Negative 3 plus 6 will give me a positive 3. And if I multiply them, right, negative 18. So I got a negative 3 and a positive 6. So there we go. I forgot to put in my x's in my binomial. And we got a minus 3 and a plus 6. And I'm done. And let's look at, let's just think about how I would start this. I know it's x and x. What would my signs be in here, you think? They got to multiply to a negative 20, right? So one's got to be positive, one's got to be negative. I know that. And if I go through negative 20, they got to add up to a negative 1, don't they? There's an imaginary 1 there. So they got to add up to a negative 1. And in this case, 5 times 4, but which one's going to be negative? We need that 5 to be negative, don't we? So minus 5, positive 4. I went through that kind of quick. I just want to get to this last one here. If you take a look, it's not in our standard form. We got to get that x squared first. I'm going to rewrite this. Minus 22x plus 40. Okay, I know it's going to factor into a product of two binomials. I know my first term is x. And this is kind of like that number 1. They're going to both be negative, right? Because I need factors of 40 that add up to negative 22. Right? So they're both going to be negative. I don't think it's going to be negative 1 and negative 40, right? Those aren't going to add up to. Let's go to the next one. Negative 2 times negative 20. That looks pretty good, doesn't it? Negative 2 and negative 20, they add up to negative 22. So there we go. Minus 2, minus 20, and I'm done. Okay, and this is nice being able to factor, because if we want to solve an equation now, if I can get it equal to 0, all I got to do is factor, and it's easy to solve. So I look at my first one here, number 1. I just want to get this equal to 0, and I'll show you why. So I want to get the right side to 0, right side of the equal sign. So I'm going to subtract 15, bring it over here. So I x squared plus 2x. They're not like terms, so I can't do anything. I just got to write it at the end. Equals 0, right? That's gone. So I got 0 over there. So do the same thing. Go ahead and factor. Product of two binomials, and it's going to be equal to 0. Make my big X. And I need factors of negative 15, right, that add up to a positive 2, the number in front of my x, my b term. So one's going to be positive, one's going to be negative. And I'm going to skip the 1 times negative 15. I know those aren't going to work. So let's go with 3 times negative 5 and negative 3 times 5. I think one of those works. And if I take a look, I need a positive 2. So negative 3 and 5, they add up to a positive 2. And they multiply to a negative 15. So there we go. X minus 3, x plus 5. Well, I'm not quite done. I want to solve for x here. Well, if I take a look, this is just like the other day. Only one of these has to be 0 for the whole thing to be 0. So if I look, how can I make this first one 0? By plugging in a 3 for x, right? 3 minus 3 is 0. So I know x equals 3. Right? If I plugged in the 3 for the next spot, 3 plus 5 is 8, but 0 times 8 is 0. So it doesn't really matter what that was. And then I also got to look at the second one. How do I make the second one 0? Well, plug in a negative 5, right? Negative 5 plus 5 is 0. So x equals 3 and negative 5. And this next one I'm going to go through pretty quick. Just make sure we got to get it equal to 0, right? For our quadratics, what we'll talk about in the future is that we want to find the roots. So I got to get this negative 18 to the other side, 18d. So I got to add it. And we're left with d squared. Well, I don't want to put that 18d at the end because that's really my b term, right? I want the c at the end. So let's write this in standard form. There we go. So now we can factor this into a product of two binomials. Still equal to 0 at the end, all right? So factors of 56 that add up to a positive 18, which in this case, I'm just going to go through this quickly, I believe are 4 and a 14. 4 times 14 is 56, and 4 plus 14 is 18. So I got d now, plus 4. I'm just changing an x to a d. d plus 14. And to solve, right, set equal to 0, set each one equal to 0. So this first one I need d to be negative 4. So d equals negative 4. Doesn't matter what the next one is. And this one I need negative 14. So negative 4 and negative 14 would be my answer. There you go.